Welcome friends to my YouTube channel. Now in today's lecture I shall going to discuss the, the excess pressure inside a curved surface. Now on previous lecture I have mentioned about the different cases, and in every case it has been found that the excess pressure always lies in the concave side. Now in this lecture we are going to find out the amount of excess pressure inside a curved surface. So just draw a curved surface. So say this is A, B, C, D, and this is say A dash, B dash, C dash, D dash, and this distance say small distance is dz. This is say O1, the radius of curvature R1, and this is obviously O2, this is R2. Okay, say this is X, this is Y. Okay, and this is X plus say dx, and this is y plus dy. Now ABCD is the rectangular slice, okay, whose sides are of length xy. That is, ABCD is a slice, rectangular slice. The sides are of length x and y. That is, AB equals to x and BC equals to y. Fine. Now, as we know that the excess pressure always lies in the concave side, that means this side. So the excess pressure lies in the concave side. So due to this excess pressure, the ABCD will be pushed forward. Okay, the excess pressure will try to push forward the slice ABCD. Okay, so due to excess pressure in concave side, the ABCD section is pushed forward. Okay, so that it displaces a small distance dz. This is the dz, okay, and occupies the position A dash, B dash, C dash, D dash. Okay, due to the excess pressure in the concave side, the excess pressure will try to push the section ABCD in the upward direction. As a result, it will displace. So this is the length of the displacement, and after this displacement, ABCD will capture the position A dash, B dash, C dash. Fine. So if ABCD becomes A dash, B dash, C dash, then the length of the sides will also change. Okay, the length of the sides will also change. So now it becomes A dash, B dash, C dash, D dash. Now its length are A dash, B dash is what? X plus say dx, and say B dash, C dash is now become y plus dy. Okay, so what would be the increase in area? So at first we have to calculate the increase in area. So what will be the final area? Length into breadth, and what is the initial area? xy. So we can write x dy plus y dx. Fine. Here we have ignored the term dx dy because it is very small. So this is the increase in area. Okay, So this is the increase in area. Now from the similarity of triangles, that is from delta, say AB, say this is O1, AB O1 and delta A dash B dash O1. What we can write? This by this equals to this by, say, this. Okay, that is x plus dx by x, that we can write. This is dz, that means r1 plus dz by r1. This by this equal to this by this. Okay, so from which we can write dx by x, this is equals to dz by r1. So what will be my dx? X by r1 dz. Fine, dx is this x by r1 dz. Okay, now if we look back into this triangle, that is BCO2 and delta B dash C dash O2. Similarly, y plus dy by y, this equals to R2 plus dz by R2. So this is what? Dy by y, this is equals to dz by R2. And what will be my dy? Y by R2 dz. Okay, now we have to substitute these values in the previous expression. So what will be the increase in surface area? Okay, so what would be the increase in surface area? So increase in area, that we have found x dy plus y dx. So dy, that we found what? Y by r2 into dz, and dx, that we find x by r1 into dz. So if we take x, y, dz common, so it will be 1 by r1 plus 1 by r2. So what will be my increase in surface energy? If we multiply this with surface tension, so we will get the increase in surface energy. Okay, so increase in surface energy, increase in surface energy means surface tension multiplied by increase in surface area, that we are discussed earlier. So this is the expression of surface energy. Now when due to excess pressure ABCD is pushed forward, that means some work is done on the system. So what will be the work done on the system? Work done on the system when it is pushed forward, that means force multiplied by displacement. Displacement is this dz, and what is force? Pressure multiplied by area. Say the excess pressure in the concave side is P, and what is the initial area? xy. Okay, this is the displacement and this is the force. If we denote P as the excess pressure in the concave side and this is the area, so this is the work done. Now you all know this is the area and this is work done and this is energy, both are equal under equilibrium. So under equilibrium these two terms are equal. Okay, under equilibrium these two terms are equal, that means P into xy into dz, this is xy dz 1 by r1 upon 1 by r2. So xy dz cancels. So what is P? This is simply this. Now what happens for a spherical surface? This is the general expression for concave excess pressure in a concave site. Now for spherical surface, what happens? We all know R1 equal to R2 equal to R. So P is what? 2s by R. Okay. But whenever you take a spherical film, then there are two surfaces. So if we have to multiply this, okay, for spherical film, there are two surfaces, forward and backward. As a result, P is what? 2 multiplied by 2s by R. That we did in the last class, and it agrees excellently with the previous result obtained. Okay, so in today's lecture I shall discuss the amount of pressure, that is excess pressure, in the concave side, and we take the example of spherical surface. Okay, now in our next class we will discuss about this for cylindrical surfaces. Okay, so dear guys, kindly like and subscribe my channel for latest videos. Okay, and share it to your friends. Okay, thank you.